All right, this is going to be a hopefully pretty short video just to look at set notation, so the language of probability that we use. So we're all on the same page and we know what all the different symbols mean and that sort of thing. Now, a set is basically a group of things. Okay, we call these things elements. So your set might be the names of people that like a particular thing. It might be the numbers on a die. It might be the colors of balls in a bag, right? It's a group of things that you're looking at. Your sample space, which we've already looked at, we know is all possible elements. Okay, so if your set is the names of a group of people that like a particular thing, you might have multiple sets talking about flavors of pizza, for example. Your sample space is going to be all of the people that are in all of the different sets. So we sometimes call this the universal set. Right? And the symbols that we use for it are usually an S, a big U, although that's less common, so I might erase that. You can use the symbol omega, but I'm pretty sure that's omega. Sorry, Mr. Alathinos, if it's not. That's less common, or a big old squiggly Greek letter that I'm not sure the name of and I can't draw very well because it's really hard to use. So most of the time I'll just use an S or a U because those are easy to draw and aren't going to take up too much of my time. Okay, so I've come up with a little set here to help kind of explain the notation a little more because I think having an example makes it a bit easier. So my universal set here is Bob, Carl, Daz, Evan, and Fred. Is 5 people, right? 5 friends. I've got set A, which is the people that like Coke, drink Coca-Cola. Okay, and in that set, I've got Bob and Carl. Set B are the friends that like Pepsi, and in that we've got Bob, Daz, Evan, and Fred. So there are 2 sets, and we've got our universal set. So these are our things that we're working with. Now, an intersection, we represent it with a symbol that looks like an N. Okay, it's like a little round N. We can think of an intersection as being an AND. So if we have A intersection B, that's everything that is in not everything, it's the things that are in both set A and set B. Okay, so in set A and set B. So in this case, the set that is the intersection of A and B are the ones that are in both sets. So Bob is in both sets. So this set would just be Bob, right? Because he falls into both sections. Union, which we can think of as an OR, is represented with a little U. So it's like the intersection, but upside down. If we have A union B, it's in set A or set B. Okay, and that doesn't have to be an exclusive, so it can be either set A or set B or both. If it's not both, usually the question will specify. So if we want to see what's in A union B, that's going to be everything that's in set A or in set B. So that's going to be Bob, Carl, Daz, Evan, and Fred. So in this case, our set that's in the union is actually the same as our universal set because everyone is falling into one of the 2 categories. The complement is represented with a little apostrophe, right? So if we were to say the complement of A, that basically means not in A. So everything that is not in set A. So in this case, if we were to do A, everything that is not a part of A, including the crossover part. So because even though Bob is in set B, He's in set A, which means he can't be a part of the complement of A. So that's just going to be Daz, Evan, and Fred. Remember, we're using those squiggly brackets to denote our sets, just like in the last video, rather. And the probability, once we start assigning numbers to things, the probability of A dash, or the complement of A, I tend to call it A dash because you've got the little apostrophe, is going to be 1 minus the probability of A, just like we were doing last time. Now, an empty set is when you've got nothing, right? You've defined a set where there's actually no element. So let's say that Bob decides he only likes Coke, right? So let's say Bob is no longer in set B, he's only in set A. In that case, then we would have the intersection would have nothing in it, right? So it's just going to be a set that is empty. So you can either represent that as just the squiggly brackets with nothing in them, or you can use a circle with a line through it. I like that one because it's very unambiguous. It looks like you haven't just forgotten to put anything in. You've gone, there is literally nothing in that set. If the intersection is a null set or an empty set, then A and B are what we call mutually exclusive. Which just means that they share no elements whatsoever. Now, all of these things can be combined, so you can end up with sets that are like A and the intersection of not B, which would effectively be only the set of A. So that basically means just A. You could have A intersection B and the complement of all of that. So that would mean everything that's not the intersection point. So everything that's not across both sets and so on. You can have all sorts of different combinations of that symbol. Hopefully that all makes sense. And that's going to help you when we start looking at Venn diagrams and two-way tables and all of that thing, because it's a very symbolic sort of topic. And so now we've got all the symbols, we know what they all mean.